Hello, space explorers. Have you ever thought about what makes your smartphone, your computer, or even an electric car work? It's not magic, it's science, and that science depends on some very special ingredients from our planet called rare earth minerals. These are metals with names like neodymium and rhodium. They are super important for all the amazing technology we use every day. From the magnets in our headphones to the powerful systems in our hospitals, these minerals are the building blocks of our modern world. Without them, our gadgets would simply not exist as we know them today. The problem is, these minerals are becoming harder to get. While they are called rare, they are found in many places, but it's very difficult to mine them and prepare them for use. Right now, one country, China, processes over 90% of the world's supply. As we saw just this month, on October 9, 2025, they decided to limit how much they sell to other countries. This makes everyone else very nervous. When one place has most of a critical resource, it creates a fragile situation. It's like if only one store in your entire city sold batteries. What would you do if it suddenly closed? This situation has world leaders and scientists thinking hard. Our planet has a limited supply of these easily accessible minerals. The way we dig them up also causes a lot of damage to our environment, creating pollution and using tons of energy. For every kilogram of a metal like platinum we mine on Earth, we can release 40,000 kilograms of carbon dioxide into our atmosphere. That's a huge environmental price to pay for our technology. We are at a crossroads where we need more and more of these materials, but our planet is asking us to find a better, cleaner way to get them. So what's the answer? Do we stop making new technology? Of course not. We are innovators, after all. We need to look for a new source, a bigger supply closet. And the biggest one we know of is right above our heads. Space. The asteroids and even our own moon are packed with the very same minerals that are causing so much worry down here on Earth. This isn't science fiction anymore. It's becoming a real, practical solution to one of humanity's biggest challenges. We just have to be bold enough to go and get it. Consider it. When you look up at the night sky, you see stars, planets, and our beautiful moon. But what if I told you that you're also looking at a giant floating treasure chest? Scientists have discovered that asteroids, those big rocks tumbling through space, are loaded with valuable resources. We're talking about iron, nickel, platinum, and yes, those all-important rare earth minerals. NASA's Psyche mission, launched back in October 2023, is on its way right now to an asteroid made almost entirely of metal. It's like a giant floating mine, just waiting to be studied. And it will get there in 2029. Now you might be thinking, Bill, shouldn't we be focused on sending people to Mars? That's a fantastic goal, and I believe we will get there. But sending humans on such a long journey is incredibly complex and takes a very long time. We need to develop life support systems that can last for years. Robotic space mining, on the other hand, is something we can do much sooner. The technology is closer than you think. A mission to a nearby asteroid could take months, not years, and bring back materials that we desperately need right here, right now. It's about prioritizing the next logical step. Think about the sheer amount of resources out there. Just one asteroid could contain more platinum than has ever been mined in all of human history. The economic numbers are mind-boggling. Some experts, like astrophysicist Neil deGrasse Tyson, predict that the world's first trillionaire will make their fortune by mining asteroids. The total value is almost impossible to imagine. For example, just the 10 most promising near-Earth asteroids could hold resources worth up to $1.5 trillion. That's enough to completely change our global economy and fuel innovation for centuries to come. It's an investment in our future. This isn't just a dream. We have already proven we can do it. In 2023, NASA's OSIRIS-REx mission successfully brought back a sample from the asteroid Bennu. It was a historic moment that showed we have the skill to travel to an asteroid, grab a piece of it, and bring it home safely. This successful mission was like the first step in a much grander journey. It gave scientists the confidence and the data they need to plan for bigger missions. It proved that reaching out and touching an asteroid is no longer just a story in a movie. So, how do we actually mine an asteroid floating millions of kilometers away? The answer is simple and elegant. We send in the robots. Robotic spacecraft are the perfect workers for this job. They don't need to breathe, eat, or sleep. they can handle the extreme temperatures and radiation of space without any complaints. This makes the missions much safer because we are not putting human lives at risk on these dangerous and distant journeys. Using robots means we can go to places and do things that would be far too hazardous for any human astronaut. These robotic missions can also be developed much more quickly than a human mission to Mars. Think about all the things a human needs for a long trip: air, water, food, and a spaceship big enough to live in for years. A robot needs none of that. It just needs solar panels for power and a computer for a brain. This simplicity allows companies to design and launch missions faster. We are already seeing this happen. A company called Astroforge launched its first spacecraft, Odin, in February of this year to check out an asteroid. Even though they lost contact, they are already building the next one, showing how quickly they can move. Several companies are racing to become the first successful space miners. In the United Kingdom, the Asteroid Mining Corporation is planning to send a robot to the moon to practice its digging techniques. Another American company, Transastra, is testing a cool idea on the International Space Station in 2025. A giant capture bag designed to wrap around a small asteroid. These are not just ideas on a whiteboard. These are real pieces of hardware being built and tested today. This is the new space race, and it's driven by innovation and the promise of incredible rewards. The work is done by these autonomous machines. A robotic lander would arrive at an asteroid, anchor itself to the surface, and deploy drills or scoops to collect the rocky material, which we call regolith. Some designs even propose heating this material right there in space to separate the valuable metals from the rest of the rock. The refined metals could then be sent back to Earth in small return capsules. It's a clean, efficient, and highly automated process. It's like having a factory in space, working for us 24/7. One of the most exciting things about space mining is what it means for our home planet. Terrestrial mining, digging into the Earth, is a messy business. It can pollute our water, scar our landscapes, and, as we talked about, release enormous amounts of greenhouse gases that contribute to climate change. By moving this heavy industry off-world, we can give our planet a much-needed break. Imagine getting all the platinum we need, while producing only a tiny fraction of the CO2. A 2018 study showed space mining could be over 250 times cleaner for platinum. That's a huge win for Earth's environment. Beyond protecting our planet, space mining also provides incredible strategic value. Right now, the world depends on a small number of countries for the materials that power our digital age. This can lead to political tension and unstable supply chains, as we are seeing today. By developing our own source of minerals from space, nations can become more independent and secure. It ensures that our ability to innovate and build the technologies of tomorrow isn't controlled by anyone else. It's not just about getting rich, it's about securing our future. Furthermore, the resources we find in space don't all have to come back to Earth. Some asteroids are full of water ice. Water is one of the most useful things you can have in space. We can split it into hydrogen and oxygen to make breathable air for astronauts or, more importantly, rocket fuel. This means we could build gas stations in space. An asteroid mining outpost could refuel missions heading deeper into the solar system, like to Mars and beyond. It creates a sustainable infrastructure that makes all space exploration easier and cheaper. So, when we weigh our options, robotic space mining emerges as a truly brilliant path forward. It's faster and more achievable in the short term than sending people to Mars. It promises to solve our resource crisis, protect our precious environment, and create a foundation for an amazing future of exploration. We are standing at the beginning of a new chapter in human history, one where we reach out to the cosmos not just to explore, but to build a better, more sustainable world. It's an incredible time to be alive. Thank you for joining me on this journey into the future. With tensions rising over Earth's limited resources, the case for space mining is stronger than ever. If you found this as exciting as I do, please follow for more stories about science, space, and the amazing world of innovation. Thank you for watching Space Mining, the future of rare earth minerals. If you enjoyed this video, please like, subscribe, and hit the notification bell for more fascinating content. See you in the next adventure.